Okay, this is really important in C2, solving simple trig equations. Okay, some revision from GCSE. You're expected to know the sine graph. And let's plot some values: 0, 90, 180, 270, 360. And if we plot, now you should know this off by heart. If you don't, you're going to have to start doing some stuff on your calculator. Sine of 0, make sure your calculator's in degrees, is 0. Sine of 90 is 1. Sine of 180 is 0. Sine of 270 is -1. And sine of 360 is 0. Okay, so the sine graph looks like this. Things to notice are that it can keep going forever and ever and ever that way, and it can keep going forever and ever that way, okay? And also that it goes from 1 to -1. That's its limit, okay? The cos graph, so again, I want you to be able to sketch this very fast. 90, 180, 270, 360. And the cos graph, cos of 0 is 1, cos of 90, 0, 180 is -1. 270 is 0 and the cos of 360 is 1. And so it looks like that. Okay, so it just looks like, it looks a bit more symmetrical than that actually. It just looks like the sine graph, except it's translated, which way is it translated? It's translated 90 left, isn't it? Okay, so then obviously it keeps going round and round and round, and again the limits are from 1 to -1. Okay, so the last one obviously is the tan. And with the tan, let's put some limits in: 0, 90, 180, 270, 360. The tan of 0 is 0, the tan of 180 is, and the tan of 360 is. Now the tan of 90, if you put tan of 90 in your calculator will tell you error, which means there's a thing called an asymptote there, and also it will give you an error for the tan of 270, so asymptotes. If you do the tan of 90, you'll get 57. And if you do the tan of 1, you'll get something tiny. So the graph goes like that. If you do the tan of 91, you'll get -57. And the tan of 269, you'll get 57. And so the graph turns like so. Okay, so there's the graph. And of course it will keep going down. So it can go all the way down into the -90s. And it will go up and it will keep going and going and going. Okay, so those are the graphs. The other thing to say is, of course, that's in degrees. We've learnt about radians. So obviously I could have all my axes labelled. Let's do it on this one, 0. This could be pi over 2. This could be pi. 360 is 2 pi, and halfway between pi and 2 pi is 1.5 pi. So 3 pi over 2. All right, so we could have the axes labelled with that. Coming back to the tan graph, by the way, do you guys notice that there are no limits? All right, the tan graph is limitless. It doesn't go between 1 and -1. There are no limits. Okay. Okay, we're going to put those graphs into practice so that we can solve what are called simple trig equations. So we're going to solve sine x equals √3/2. We're going to find a value for x that lies between, this is called our range, lies between 0 and 360. So what we're going to have to do to get x is we're going to have to get rid of this sine value. Now, in order to get rid of a sine, what we actually do is an operation called inverse sine. And that's what it looks like on your calculator. It's just above the sine button. It does not mean 1 over sine x, all right? That's not the same. It just means inverse sine, sometimes called arc sine. Most of the time inverse sine. So I'm going to inverse sine both sides of the graph. So what I'm going to do is write out that I've inverse signed the left, hence he's disappeared, and I'm going to inverse sine the right, and I'm going to get this. Now when you do the inverse sine, which you can find on the button above your sine graph, I have to go shift on mine. When I do that button, I get 60 degrees. Okay, now, so there's one answer. Now, there are actually more answers than that. I'm going to show you where the other answers come from. If we take the whole of the left of the equation, this is the graph of sine x. So I'm going to graph sine x like so. 0, 90, 180, 270, 360. And then what I've got here on the right of my graph here is I've got the graph of √3/2. So y equals √3/2. Now √3/2 is roughly about there. It's a bit less than 1. It goes between 1 and -1, doesn't it, the graph? And so that is the graph y equals root 3 over 2. So what I've actually done in solving this is I've found out where the green sine graph hits, the green y equals sine x graph hits the blue y equals root 3 over 2 graph. And you can see that it hits here and it hits here. So one of those is 60. Now if you look at it, you can see that this one must be 60. So what you'll see me do is draw the line down, and then I often shade in that little bit and say that little bit there is 60. Now all you're going to do now is use your symmetry of your graph. I can instantly see, if I drop this little perpendicular, that this value must be 180 minus 60. So using the symmetry of my graph, 180 minus 60 means that my answers are x equals 60 or x equals 120. Done. And if I'm not sure, what I can do is I can substitute 60 into there. So do sine 60 and check that I get root 3 over 2. And I can do sine 120 and check I get root 3 over 2. Now the next one's exactly the same. The only thing that's different is I've changed the range. So now what I'm doing is I'm not working in degrees anymore. I'm working in radians. Okay, so I can do two things. I can either say to myself that when I was working in degrees, I got 60 or 120. So I can do the whole thing through in degrees. Then I can change it to radians. Okay, who can remember the conversion for radians? Pi radians is 180 degrees. So 1 degree is pi divided by 180. So if I've got degrees and I want to go back to radians, I've got to times by pi over 180. So x is 60 pi over 180, and that will cancel to give me x equals pi over 3, or 120 pi over 180. Those will cancel, and 12/18 will give me, will that go 6? So it will be 2/3 or 2 pi over 3. So that's one thing I can do. The second thing that I can do is, if I don't want to do that, I can change my calculator into radians by going into the degree setting. I tend to go into shift mode, which gives me into the setup, and then you can change it into radians. And then all you need to do is that when you draw your graph out, so you'll go x equals inverse sine of root 3 over 2. So x is, now your calculator won't tell you 60, what it will tell you is it will tell you pi over 3. Okay, so if our calculator mode is in radians, your calculator should come up with pi over 3. And then it's just a case of drawing it again. So you would go 0. Now instead of 90, it's pi over 2. Instead of 180, it's pi. Then it's 3 pi over 2, and then it's 2 pi. And then it's exactly the same idea as before. So we're wanting to find out where that cuts root 3 over 2. So it cuts it there and there. It must cut it here, so that must be pi over 3 because that's a third pi, and therefore in here, that distance there must be or pi minus pi over 3. Okay, so you'd have to have a little bit of a think about how we did that. That's going to be 3 pi over 3 minus pi over 3, which gives us 2 pi over 3. So there's the first answer and there's the second answer. Now, I don't mind which way round you do it. I personally often think it's easier to work in degrees and then change it to radians at the end, but mathematically that's not perfectly brilliant. So if you want to be a perfect mathematician, do the whole thing through in radians. If you want to be a bit of a fudgy mathematician, you can go in degrees and then change it. You kind of can do what you like. Okay, here comes the next one. Cos x is minus root 3 over 2. So on this one, we're going to get rid of the cos by doing the inverse cos to both sides. So we're going to go x equals inverse cos of minus root 3 over 2. Okay, and the minus root 3 over 2 is all in a bracket. Now, when I do that, my calculator tells me 150 degrees. Okay, so that's my first answer. Okay, so let's go and see what that looks like on the graph. So here is my cos graph. Here comes my cos. All right, you need to know your cos off by heart. 0, 90, 180, 270, 360. Here comes minus root 3 over 2. Minus root 3 over 2 is down here somewhere, isn't it? All right, so there it goes. And I want the place where they cut. So they cut there and they cut there. Now looking at the graph, 150 must be here, mustn't it? That must be 150 there. Now I personally do lots of stuff with these little areas here. So I reckon that that little area there is between 150 and 90. So I think the difference is 60. All right, that little area from there to there is 60, which means that if I put him up, that little area from there to there is also 60. So I think by the symmetry of the graph, it looks like it's 270 minus 60. So my answer is x is 150 or it's 210 degrees. All right, and if you're not sure, feed it back into there and double check that you get that right. Next one. Right, solve 2 tan x is minus 2. Now with this one, can you see there's this silly 2 in the way? So what we need to do is we need to get it so that it's sine x or cos x or tan x equals something. So the first thing I'm going to do with this one is divide both sides by 2. So I get tan x equals minus 1. Okay, the next thing I'm going to do is get rid of the tan. So x is inverse tan of minus 1. And when I do the inverse tan of minus 1, I get minus 45. Now, don't panic, all right? Everyone panics at this point. There's nothing to panic about. We're just going to graph it, okay? So we're going to graph what we have. So here comes my tan graph being graphed, okay? 0, 90, there's my asymptote. Around like that, 180, asymptote, 270, bump, 360. Okay, there's my tan graph. Now, what I'm doing is I'm doing tan x equals minus 1. So if I graph now the minus 1 is down here. Okay, so minus 45. Now, I can't actually, it crosses there. That doesn't look like minus 45. And it crosses there. That doesn't look like minus 45. But if you extend your graph, because let's forget, the graphs can go on forever and ever and ever in either direction, I think minus 45 is looking here. All right, now that makes sense because that asymptote is minus 90. So I think that minus 45 is here, which means that this distance between here and here, okay, it's a minus 45, but actually the physical distance is 45. Now, if you look at your symmetry of your curve, that's come back to the left from 0. So it's come back to the left from 0. So I think the other answer will be 180 minus 45, or there's another one back from the left from 0. So I think this one here is 360 minus 45. So let's neaten those up. I think the answer is minus 45, or 180 minus 45 is 135, or 360 minus 45 is 315. And if I look at my range, I only want answers between 0 and 360, so I cross him off with these two remaining.